Good morning, dear students. Today we are going to look at the nuclear stability curve. So the nuclear stability curve determines whether the nucleus is stable or not. So in this lecture, we will plot the number of neutrons with respect to the number of protons of each atom. Depending on, you see the number of protons is equal to the atomic number, whereas the number of neutrons plus the number of protons would give you the mass number. So ideally, if the number of protons and number of neutrons have to be same, then you see it should follow this straight line. So 1:1 neutron to proton ratio. But that never happens. What we have seen is actually if you plot the existing nuclei with the number of neutrons and the number of protons, what you would see is actually they will all lie above the straight line. One of the main reasons is that as you increase, you see that when it is very low, then the atomic mass number is very low. That means when the number of protons is very low, then you will see that the number of neutrons is more or less equal to the number of protons. But as the number of protons increases, the number of neutrons increases more than the number of protons. So in this case, if you have the number of protons as 40, then the number of neutrons is nearly 50. So when the number of neutrons, that is when the mass number is 40, then there the number of neutrons is nearly 50. So it keeps on increasing. For example, here 80 is the number of protons, so the number of neutrons would be 120. Why do you think that the number of protons when increases, the number of neutrons increases? That is mainly because the nucleus wants to hold all the particles tight, and for this to happen, we all know that the nuclear force is independent of the charge, but there is a strong Coulombic repulsion when you have the number of protons more in number. So when the number of protons are more in number, more strong Coulombic repulsion is there, which is trying to blow open the nucleus to counteract. You cannot have more protons, but what you will have is more electrically neutral neutrons inside the nucleus, so that they will constitute more towards the nuclear force, and this nuclear force would be much greater than the Coulomb repulsion between the similar protons, because protons are all positively charged. We all know that protons are positively charged, and positive charges repel, negative charges repel, and here since we have a proton which is positively charged, is going to repel it. Two protons are going to repel, and when there are more protons, they are all going to repel each other. So there will be a very good electrostatic pressure inside, and to counteract, to increase the nuclear force, we have a large number of neutrons compared to the protons as you go up in atomic number.